most basic types of functions that we can work with is what's called a linear function. There are various ways of defining these, and various definitions are more or less useful in various contexts. But a fairly standard definition in a basic algebra class is that a linear function is one that can be written in the form f of x equals a number m times x plus another number b. So in this f of x equals mx plus b, this m and this b are numbers. So the only variable is x. And this is a good definition, except that it has this phrase, can be written. What that means is, after we do all of our simplifying, we end up with an expression in the form mx plus b for our function. But the thing is that means that we can't just look at a function however it's presented and decide right away whether or not it's linear. We have to do all of our simplifying first. So we're going to present a different definition that lets us just look at something and see whether or not it's linear. A linear expression is one in which only a limited set of operations appear. They can have whatever addition and subtraction we like, but there can be multiplication and division only by numbers. So we can have two numbers multiplied together, we can have a number multiplied by a variable, we can have a number divided by a variable, but we can't multiply together two variables, and we can't divide by a variable. And then we also can't do any other stuff. So a linear expression has addition, subtraction, and only multiplication and division by numbers. A linear equation is one in which the expressions on each side are linear, and a linear function is one in the form f of x equals a linear expression. So linear equations and linear functions are given in terms of linear expressions. So just to practice with this definition, we have a few expressions, and we're going to say why they're not linear. In this first expression, we see this 1 over x. And so we're dividing by a variable. So since we're dividing by a variable in this expression, which is not allowed in linear expressions, this is not linear. It's just division by variables that isn't allowed. So we can have like x over 3, for example. We're allowed to have a variable divided by a number, but we can't divide by a variable. In this next expression, we have a square root of x minus 5. And square roots are not on the list. Linear expressions can't include a variable inside a square root, because that's not addition, subtraction, it's not multiplication or division by numbers. Now, technically speaking, we could have something like a square root of 5. That's just a number. We can put whatever numbers we want in, but we can't do things like that to variables in something linear. In this next expression, the culprit is this xy term. In linear expressions, we can't multiply variables together. We could have 2x, we could have 2y, but we can't have 2xy. And finally, in this last expression, we're not directly multiplying variables together, but we are multiplying together factors that contain variables. And so variable expressions are still being multiplied together. Now, all of these are perfectly good expressions. They're all expressions that we're going to see before the end of the semester, possibly except for that third one. But they're not linear expressions. So when we're limiting ourselves to what's linear, these are not allowed. Now, a couple of quick notes. Depending on the context, we may or may not think of an expression with no variables, that is, a constant expression, as linear. For our purposes, we're going to say no. Constants are not linear. And that's because we're going to want to say some things about all linear functions that don't apply to constants. One other very technical note that you don't normally get in a basic algebra class, but I have to say it as an algebraist. Technically, the functions we're calling linear are more properly referred to as affine, and linear only applies to a subset of them. We're going to ignore this issue for the rest of this course, but you should be aware as you get on into later math, the definition of linear is going to be revised slightly.